Hello students, we have started the topic that is quadrilateral, that is chapter number 5 from mathematics 2. In this chapter we have already learned about the properties of, that is different properties of different quadrilaterals. Then we have discussed about the properties of all type of quadrilaterals, that is properties of parallelogram, properties of rhombus, properties of square, properties of rectangle and properties of kite also. Then we have to prove the few properties which is related with that particular quadrilateral. Therefore, first we will discussing on the parallelogram, that is properties of parallelogram, which we have to prove in the form of theorem. Already we have started to study about the properties of parallelogram, and there are two theorems which is related with the parallelogram we have already studied in offline studies. Therefore, I am going to discuss you about the remaining few properties of parallelogram which we have to prove in the form of theorem. Here we have already solved the examples which is based on properties of parallelogram from practice set 5.1. All of you studied about the properties of parallelogram, and here converse of properties of parallelogram that we have to prove here, and that is which is given in the form of test for parallelogram. Then one of the test for parallelogram, that is, see here, if pairs of opposite sides of a quadrilateral are congruent, then see here, in this property, here the part which is given after if, that which is a given part, and what is here given, that is if pairs of opposite sides of quadrilateral. That means here the quadrilateral which is given, we don't know whether it is a parallelogram or not. We have to prove that it is a parallelogram. That means, see here quadrilateral ABCD is given, in which pairs of opposite sides of quadrilateral are congruent. That means here in this quadrilateral AD congruent BC is given, as well as AB congruent CD is given also. That is, here pairs of opposite sides of quadrilateral are congruent. Then see here, then it is a parallelogram. That means here the part which is after then, we have to prove that, and the part which is given after if, that condition which is given here. Therefore, when we have to prove any properties, that is which is related with that quadrilateral, then the part which is given after if, that is written in the form of given and with the help of diagram. Then see here in figure, quadrilateral ABCD is given here. Then we have to write in given, that is in quadrilateral ABCD, here the part which is given here, that is AB congruent CD, and here AD congruent BC. Then that is the given part which is given in the property of that quadrilateral. Therefore, we have to write this in given. Then we have to prove that given quadrilateral, we don't know that given quadrilateral ABCD is parallelogram or not. We have to prove that this quadrilateral is parallelogram. Therefore, we have to prove that quadrilateral ABCD is a parallelogram. It is a parallelogram. Then we have to prove this, that is quadrilateral ABCD is a parallelogram. Then if we have to prove that this quadrilateral is parallelogram, then we have to prove that opposite pairs of sides, they are parallel in nature. Therefore, first of all, we have to do some construction to prove this property. Then see here, we have to draw any one diagonal, that AC or BD. We have to draw here. Therefore, see here, if we draw the diagonal AC, then because of that diagonal, there are two triangles are formed. Then construction which is here done, that is diagonal AC is drawn. Therefore, there are two triangles are formed here. Then we have to prove that. Then here proof is given on the basis of the part which is, or the property which is given, that is here, that is in this quadrilateral ABCD, AB congruent CD. Therefore, we have to write the property which is given here, that is in quadrilateral ABCD, here AB congruent CD, isn't it? And here is AD congruent BC and AD congruent, that is BC, that is which is given. Then see here, due to diagonal, there are two triangles are formed. Therefore, in triangle ADC, and triangle, see here, CBA, triangle CBA. In those two triangles, see here, the side AD of first triangle is congruent with side BC of second triangle. See here, this side of triangle ADC is congruent with the side BC of triangle CBA. Therefore, see here, AD congruent BC, that is which is given. Then again see here, this side of the triangle ADC, that is CD of triangle ADC, CD congruent side AB of this triangle CBA, that is congruent AB, which is also given in the given property. Then see here, one more side, that is AC of this triangle, and here AC of this second triangle, that is AC of ADC triangle and AC of CBA triangle are also congruent, that is here AC congruent AC, which is common side. which is common side. Therefore, here triangle ADC congruent triangle CBA. Those both triangles are congruent because here according to the yes test. See here, by yes test. Therefore, see here, those two triangles are congruent. Therefore, here the corresponding angles of those two triangles are also congruent. That means here angle, this angle, that is angle DCA of angle CDA, that is triangle CDA, and this angle of triangle CBA are congruent because these are corresponding angles of congruent triangle. Then see here, those two triangles are congruent. Therefore, those two angles are corresponding angles of those congruent triangle. Therefore, here angle DCA congruent angle, see here, BAC, those are congruent because congruent angles of, that is corresponding angles of congruent triangle. Then see here, those two triangles are congruent. Therefore, here considering AB and CD both are parallel, those two lines, and there is a AC is a transversal. Therefore, those two triangles are alternate angles. See here, AB and CD lines, of which AC is a diagonal. Therefore, and here those two angles are alternate angles, and therefore here alternate angles are congruent. Therefore, side AB parallel side CD. Therefore, here side AB parallel side CD, because here alternate angle test, considering this equation is first equation. Then again see here those two triangles are congruent by yes test. Therefore, here this angle of triangle CDA and this angle of the triangle CBA are also congruent because those two triangles are congruent. Therefore, corresponding angles of those congruent triangles are also congruent. Then see here angle DAC congruent angle, see here DAC, and angle BCA are congruent. Here those are the corresponding angles of congruent triangle. And see here, now consider those two lines, that is AD and BC sides, of which transversal is AC, and those two angles are alternate angles. See here, AD side and BC side, of which AC is a transversal, and those two angles are alternate angles which are congruent. Those two angles are alternate angles as well as congruent. As those two angles are congruent, therefore AD parallel BC. Therefore, here AD parallel BC because alternate angle test. Therefore, here we have to consider that equation number 2. Then see here, equation number 1, that is AB parallel CD. See here, AB parallel CD, as well as here AD parallel BC. AD parallel BC. Therefore, from equation 1 and 2, from equation 1 and 2, it is proved that quadrilateral ABCD is a parallelogram, because here parallelogram, because here opposite sides, pairs of sides of that quadrilateral are parallel to each other. Therefore, this quadrilateral is a parallelogram. That is the proof of that given property which is related with the parallelogram. That is one of the tests for parallelogram. Then we will discuss on another property of parallelogram, that is which is given in the test for parallelogram. See here, one more property here which is given. If both pairs of opposite angles of a quadrilateral are congruent, then it is a parallelogram. That quadrilateral is a parallelogram. Then that is the property which is given in the form of theorem. That is, we have to prove this property, and that is one of the tests for parallelogram. Then see here, we have to remind this property again, and we have to draw the diagram for it or figure for it to prove this property. See here, if both pairs of opposite angles of a quadrilateral are congruent, then we have to draw the quadrilateral in which here the opposite pairs of angles are congruent, which is given here. That means consider here E, F, G, H is any quadrilateral. That means we don't know that given quadrilateral is parallelogram or not. We have to prove that this quadrilateral is parallelogram according to given condition. Here only condition that is given, that quadrilateral EFGH is any quadrilateral. That means here we have to write that given quadrilateral EFGH. In this quadrilateral, here both pairs of opposite angles, that is angle E and angle G, are congruent. That means here angle E congruent angle G, as well as angle H and angle F are congruent. Angle H congruent angle F. That means both pairs, that is this pair of opposite angle is congruent, as well as this pair of opposite angle of this quadrilateral is congruent. Then from this given data, we have to prove that given quadrilateral, that is quadrilateral EFGH is a parallelogram. It is a parallelogram. That means we have to prove that HG parallel EF, that then H and HE parallel GF. We have to prove this from given condition or given property that is given in the theorem, in this theorem. Then here we have to give the proof for it. See here in your textbook, here the proof of this property, this theorem is given in the form of activity. Then you have to only fill the blank places which is given in this theorem. See here we have to prove that quadrilateral EFGH is a parallelogram. Then we will prove this property according to given condition. Then see here the few properties which are given about this quadrilateral. Then here in quadrilateral EFGH, in this quadrilateral angle G congruent angle E which is given here. Then as this angle G and angle E are congruent, that means of same measurement, therefore we have to consider that of x degree. Then see here angle G is equals to angle E is equals to x degree. Then similarly here angle H congruent angle F, that means the measurement of angle H is equals to angle F. Therefore we have to consider those congruent angle as a y degree. Therefore angle H is equals to angle F is equals to y degree. Then see here that property which is given, that is opposite angles of this quadrilateral are congruent. Then we have to prove that here that quadrilateral is parallelogram. Therefore from given condition, see here in quadrilateral EFGH, the property of quadrilateral, that is the measurement of sum of all measures of the angles are congruent. Therefore here angle E plus angle F plus angle G plus angle H is equals to 360 degree. That is the property of quadrilateral, of any quadrilateral. Then see here the sum of measures of all four angles of quadrilateral is 360 degree. Then see here angle E, that which is considered here x degree, plus angle F which is given here y degree, plus angle G that is x degree, and angle H that is y degree is equals to 360 degree. Therefore here 2x degree plus 2y degree is equals to 360 degree. Therefore taking common, that is 2 is taking common from it, that is 2 in bracket x plus y is equals to 360 degree. Therefore here 2 which is given at the right hand side, therefore x plus y, that means x degree plus y degree, that is equals to 360 upon 2, that is 180 degree. That means here x degree plus y degree is equals to 180 degree. But see here x degree, that means here angle G, x degree that is a measure of angle G. Therefore we have to write here angle G plus here Y degree means angle H, that is sum of angle G, measure of angle G and angle H is 180 degree. By this formula we can write angle G plus angle H is equals to 180 degree. That means see here angle G plus angle H, the sum of these two angles is 180 degree. That means those two angles are supplementary. Therefore, see here, considering here line EH and line GF, that is side EH and side GF, and here transversal HG is considering, then those triangles are interior angles. See here, that is H, here EH, that side, and here GF, that is two sides of which transversal is HG, and here this angle and this angle, those angles are interior angles. That means angle Y and angle X, that is angle G and angle H are interior angles. Therefore, here and interior angles, the measure of sum of those measures of interior angle is 180 degree. And when interior angles are supplementary or sum of measures of interior angles is 180 degree, then those two lines are parallel to each other. Therefore, from this equation we have to write that side or segment HE parallel side GF, because here alternate interior angle test is used here, that is interior angle test. According to this condition, here HE parallel side GF. Let us consider this equation number 1. Similarly, we can write that angle G plus angle F is equals to 180. From this condition or from this equation, we can write that angle X degree, that means angle G, plus angle that is Y degree, that is of angle F, that means angle G plus angle F is equals to 180 degree. Then again see here, considering that is HG side and EF side and transversal GF, therefore those are interior angles, and here interior angles, sum of those two interior angle is 180 degree. Therefore here GH parallel to that is FE or EF. Therefore here side HG or GH parallel side, that is EF. Let us consider, that is equation number 2, because interior angle test. Then from equation 1 and 2, that is here it is proved that EH parallel GF and GH parallel EF. Therefore that means EH, that is parallel to GF, that means opposite pair of that quadrilateral are parallel, and HG parallel to EF, that means that quadrilateral is parallelogram. Therefore, quadrilateral EFGH is a parallelogram. It is a parallelogram. That is the one of the test for parallelogram, that here two theorems, that is properties of two parallelogram properties here. That is the test for parallelogram. That means here the properties of parallelogram which is proved here in the form of theorem. That is the test for parallelogram. Then we will solve the few examples which is related with this property from practice set 5.2 in the next lecture. Thank you.